use and outsourcing our EMR systems, our EHR, electronic health record systems. Our internet connections from our practices are becoming more and more critical. We're really depending on them. Generally, when we're outsourcing these systems, we're using the internet as our pathway, as our connection to the application provider that's hosting these critical applications. So that's why the connection is so critical. Other things that have been coming down the pike as far as meaningful use goes, things like requirements for patient portal, access e-prescribing, secure email, being able to provide patients access to their records, beyond just a patient portal. We don't need that. Oops, clicked on the wrong thing. Hopefully my screen will come back. Sorry about that. So these are other reasons from coming from meaningful use why we depend so much on our internet connection, and we need to protect it. There are certain risks involved. We need to think about the availability of our internet circuits, for example. So it's not just protecting the confidentiality and integrity of the information. We always normally think of preventing hackers and attackers from trying to hack into our systems from the internet. But when we depend on the availability of our internet circuits to that extent, then we really need to make sure we think about some of these things on this slide here, like what happens if or when our connection to the internet goes down. So that's what I wanted to start this webinar off with, is the availability side of things. So we can add preventive measures to try to prevent our connection to the internet from going down by, generally the way of doing that is not depending on just one particular internet connection provider or ISP or one single circuit, but adding a second one, either as a backup or perhaps using them both at the same time, what we call load balancing. And normal traffic will actually use both of the connections simultaneously, and generally will improve performance as well as your uptime. So when we think about whether we're going to add a second connection, one of the things we want to think about, in addition to, geez, is it cost effective and worthwhile to do that? And when you're thinking about that, you're comparing that to the cost of downtime or lack of access to your critical systems, which may be very costly to some organizations. So if we're going to add a second connection, we want to think about, let's say we have, I don't know, Comcast as our connection. Adding another circuit from Comcast probably isn't going to add a whole lot of value. The reason being that whatever might take down your primary connection is more than likely going to take down the second connection that's going to the same provider, perhaps even over the same pair of wires. So if you're going to add a second connection, you want to think about adding from a different provider, and ideally having it come in through a different path into the building. Maybe you've got one, Comcast maybe comes in through a cable network overhead on the poles, and then maybe you've got a connection from Verizon or something coming in on fiber underground. That would be ideal. We've got some of the threats we're talking about here would be like what we like to call a backhoe attack. Generally, underground services getting damaged by construction companies or road work or something that's digging up in the streets. Whereas the overhead wires, you've got weather threats as well. Wind conditions and ice storms and electrical storms and that type of thing. So there are plenty of ways that our internet connections can go down. I'm going to pull up a quick drawing that I did for you here to try to depict what we're talking about a little bit better here. So we're going to use this drawing a couple times during this presentation. So I've got this dotted line here, and the left side of the line is the internet and everything that we have no control over. So we call this the untrusted side of the network. And then on the right-hand side of the dashed line here is our practice, our network. We've got maybe a server here that has PHI on it, for example. PCs, plenty of PCs on the LAN that have access, perhaps through a VPN connection or something, to a provider that's out here on the internet, this cloud here representing the internet. So in this drawing, this particular mythical practice has two connections to the internet and a single firewall. And so the other things that we need to think about when a circuit fails is are we going to fail over to the other circuit automatically? So here's why I wanted to show you this drawing. It's pretty easy to say, geez, if this interface on this router, maybe this is, we used Comcast and Verizon, so let's say this is Comcast's connection to the internet. If this interface here on this router fails, the firewall can detect that right away, and it's really easy to tell the firewall, well, okay, if this interface goes down, reroute all of the traffic, from these PCs and out this circuit, this Verizon connection, out to the internet and out to our providers there. But what's more likely to fail isn't the interface on the side that you can see directly, but maybe something out here. This cloud here is made up of all kinds of routers and things on the internet that we have no control over. So there's more likely to be a failure here that the firewall can't directly detect. So I just point that out because it's a little bit more complicated to really get an effective automatic failover. You may want to talk to your ISPs about things like BGP and that type of thing. Talk to your IT people. It's a little bit too technical to get into in this webinar, but it's something to think about when you're determining whether you want to consider adding a second circuit or not. Switch back to the presentation here. Get the better view here. All right, so moving on to the next slide. So we've got to make basically a risk-based decision as far as how we're going to handle these availability issues. One of the first things you want to decide is, can we afford to go down? Or like we talked about in the previous slide, how much does it really cost if we go down and lose access to our electronic medical record system or our practice management system that's outsourced, right? And of course that's going to kind of depend on how long you're going to be down for, but certainly being down for a full day due to a circuit issue is not unheard of. So maybe we have to have or we have the ability to have a contingency plan that allows us to continue operating our practice without the EMR system. Maybe you still have all of those physical records in the file cabinets right there. Maybe they've been up to date. Maybe you've just started on EMR anyway. So maybe it's actually feasible to switch back to physical records, physical charts, and that wouldn't be a huge impact, and it's actually more cost effective to do it that way than to bring in a second diversified connection to the internet. So that's one option. And the other option is to have a plan or the ability to quickly restore your connection to EMR, which generally means having that second internet provider. And either the automatic failover, if you can't have the automatic failover, then it's important to include in the plan how you achieve that failover. And I think I would recommend for smaller practices that don't have IT staff and security firewall expertise and all that to consider just outsourcing the management and monitoring of the firewall and all that, so you have somebody to call whenever you need a change made, or somebody that you can call and get very quick response in the case of a circuit failure and you need them to fail over to the other circuit manually for you. So that's another option. So cybersecurity risks, that was availability risks that we just talked about, but the majority of this afternoon we're going to talk about risks to confidentiality, integrity, and that type of thing, HIPAA security rule type stuff. So we've got all these controls that we have to have in place to prevent unauthorized access to our data and all that. We've got physical controls and technical controls and all that, but if there are ways to get into systems from the internet, it's important to remember that that access from the internet is going to just completely bypass any physical security controls you have in place. And by physical controls, I'm talking about locked doors, or the fact that to get on your network, you'd have to get into your building and plug into one of those LAN jacks on the wall or whatever. Well, this, if you're allowing access from the internet, say for remote access or something like that for your users, all of that goes right out the window, no pun intended. Also, anybody coming in from the internet, it's very difficult to know for certain who they really are. So the internet provides anonymous access for attackers, which of course the attackers love. And to make things worse, you've got no idea where they're coming from. So we've got rules and laws and so forth that protect the privacy of our connections and our data and all that that are great within the U.S. But what if the attacker is in Russia or China or some other anywhere around the world? Because as we know, the internet is all around the world. So there's no geopolitical or geographical boundaries from where these attackers may be coming from. But we can manage these risks, by basically doing the right things, and that's what we're going to talk about here. We're going to give you some recommendations for that. So the cybersecurity 10 best practices, I think is what we called this presentation, and I called it that because I kind of stole it. Well, borrowed it from the Office of the National Coordinator for Health IT. They had issued, and this was, I think it's more than a year old now, this document that I read a while ago. It's a cybersecurity guidance document for small practices that they put out. Not very long. You might want to check it out. Right here is the, put that all on one line actually, and that's the URL that will get you to the document itself. If you want to, let me get rid of that for you so you can see that. If you want to download the document and read it yourself. But we're going to talk about each of the 10 best practices that they recommend in this document. So the first one, and I don't believe they're in any particular order, by the way. If they were, I'm not sure I would totally agree with the order they put them in. But I do agree that all of them are very important. We're going to talk about them all and provide some recommendations. So strong passwords, yeah, hugely important. Why passwords when we're talking about an internet connection? Well, particularly important when you allow remote access into your network. Because if you think about it, we talked about how remote access from the internet bypasses entirely all our physical controls and other types of controls that we have in place. So really what we're left with, or most of us are left with, is just the fact that you need a valid username and password to get into the system. But anybody can get to that login screen, and anybody can guess, and in many cases take as long as they want, trying to guess a valid username and password. There are ways to get usernames, by the way, through some farming techniques and email, phishing, and all types of things that you may not have thought of. So the username is really not that difficult. And then there are automated tools to brute force a password. Brute force just trying all hundreds and hundreds of different passwords until you get in. So, and we talked about in some previous Tech Hours ways to protect passwords, like having, well, of course, strong passwords, but also having limits on the number of failed passwords that the system will allow before it disconnects this session. I think that's a huge one for when you're providing remote access. So, but password policy, very important. Also, the systems on the network that have access to, and I'm going to pull up that my drawing one more time here, lovely Visio drawing, because I put this PC here on our LAN. This is a PC like any other PC on our trusted LAN that has access to EMR. So let's say the EMR system is hosted out here, and I didn't draw the hosting provider here, but the PC goes through the outbound connection through the firewall, out to whichever is the main internet connection, and then out to the provider. But you've got bad guys out here. Here's our evil attacker on the internet. There are several different ways that he may be able to get, or she may be able to get access to this target PC on your network, and it's usually not through hacking in necessarily from the outside, but through hijacking an outbound session or getting some piece of malicious code or something, or tricking the user into going to a compromised website or a malicious website that's going to get some code onto this PC that's going to run a program that's going to allow the attacker to see the session with the your provider out here on the internet. So if you have and hopefully you do, require a password to access that application, then the attacker that's on here, if there's already a session or your EMR application is open, well then now the attacker may be able to view that. But if not, the attacker now needs to either wait for the user to log in if they can be part of that session, or they're going to have yet another password that they're going to have to try to learn or crack or whatever. So that's just another reason why having strong passwords is important, even when we're talking about the internet connections. All right, number 2. Come on, here we go. Antivirus, yeah, sure. Everybody's running antivirus software on all of their computers, right? Servers, computers, I hope so. And you should have a policy for that. This is also, required by the HIPAA security rule. So I'd recommend standardizing on a trusted company, whatever you want to use. But make sure that your policy requires that signatures be kept up to date at all the time. Signatures are the things that let's say, Symantec, McAfee, whomever it is, they're responsible for keeping these up to date. They generally are updated multiple times per week with signatures are what are used to recognize or match traffic to a known virus, which viruses are mutating and changing all the time, and new viruses are coming out all the time. Therefore, signatures are being updated and coming out all the time. And you need to have the latest signatures in order to be protected from the latest attacks and threats and viruses and malicious code and so forth. Also, don't rely 100% on your antivirus software. It's important to train your users to recognize symptoms of a potential virus attack or infection or outbreak or something. And you're going to hear me mention training users a lot. I think that's a hugely important to keep your users trained. We're going to talk about why a little bit later. And of course, we already said let's make sure it's running on all of the computers. Even if you just have one that isn't protected and that one has access to EMR, well, guess what? We kind of talked about that a few minutes ago also. Many of the firewall or they're sometimes called unified threat management appliances nowadays do more than just firewalling and preventing the bad guys on the internet from coming in from the internet into our network. They can also scan traffic for viruses, and that's sort of another gives us another layer of detecting malicious software besides what's running on our computers. If we're detecting the virus when it gets to our computer, hopefully it's not too late, but if we can detect it at the firewall, at the gateway, then we're detecting it and blocking it, hopefully, before it even gets to the computer. So that's even better. So as you're shopping around or get to the point where you're thinking about upgrading the firewall, well, consider whether you want it to be able to detect and block viruses at the gateway for you. Number 3, well, yeah, use a firewall. I kind of started off the presentation with the firewall because it's really a fundamental control, a fundamental piece of protecting us from or safely adding a connection to the internet for our practice, right? But have a policy for the firewall that not only requires the policy but states what applications or services or technical term the geeks call it, ports and protocols and so forth that the firewall allows. What do you need to allow outbound? For example, you're going to want to allow web access, okay, the technical term being HTTP, secure web access. You're going to need to allow DNS in order for web access to work, and there's a list of things that you'll talk to your IT staff about as far as what should be allowed. SMTP, perhaps for email, POP3 if you want to allow your users access to perhaps their personal email accounts and that type of thing. Also consider, as I mentioned earlier, If you don't have the expertise in-house to really properly run the firewall and operate the firewall, consider hiring a company to do that for you remotely. Um, Egress filtering, obviously the firewall is going to be only allowing a few, if any, protocols or services, we'll say, from the internet into your network, but you also want to filter or control the traffic from your network going outbound. And one of the reasons is the attack scenario that I described earlier when I had that land drawing on the screen, where the attacker is going to try to get a piece of code onto one of your PCs, and then that PC is going to establish the connection outbound with the attacker. So the attacker is going to try to leverage, if your firewall just allows anything outbound, then the attacker may find a port and or protocol that works outbound that maybe you wouldn't even notice. So if you're only allowing outbound what you really need, then you make it a little bit harder for the attacker. So that's important. Web filtering is the concept of kind of controlling what websites or categories of websites that your users are allowed to go to. And that's important for a few reasons. Maybe you just want to manage the productivity of your users and prevent them from wasting time and so forth. But also, we mentioned that one of the ways that we can get this malicious code onto your PCs is by attackers tricking your users into going to compromised or malicious websites. So this web filtering is a great way to minimize the chance of that happening. You can block based on certain categories and just rule out any types of questionable or risky categories of websites that really nobody in your practice would need access to anyways, and I think that really goes a long way. And that, again, is another example of a feature that you might want to look for as you're considering adding or upgrading your firewall. Okay. So down here, review log files. One of the core functionalities of your firewall is also logging all of the activity that goes through the firewall. And that's great as long as somebody's looking at those log files. Maybe there's an automated system watching those log files. Maybe that automated system can recognize when somebody's trying to break into your network and send an alert to somebody. Wouldn't that be great? There's a great way to identify somebody trying to break into your network. And every firewall is capable of generating log files, but by default they're not necessarily going to save any lengths of time of log files, and they're not going to automatically alert you or anything. So that's something you'll want to talk to whoever is managing and monitoring your firewall about, and it is pretty important. Again, remote access. Connecting the practice to the internet at all, is a risk in itself. But once you add remote access for your users through the internet, the risk becomes much bigger. We talked about the password issue. Well, the reason that I mentioned authentication here under use a firewall is that you can have by authentication, I mean this is the screen that your users would see when they go to establish this connection from, whether it's from their home or on the road from a laptop. Hopefully they have to type, at least put in a username and password in order to get access. But that name and password may be coming from the server that they're connecting to that's already on your internal network, which means that you have to configure your firewall to allow that login to occur all the way to your inside network. But you can configure your firewall to handle the authentication on behalf of the server. Now, no traffic gets into the internal network unless it's received a correct username and password, and that was handled by the firewall. Again, yet another feature that you might want to consider if you're looking into upgrading your firewall. And the vast majority of firewall vendors, if not all of them, would have this feature available, probably for no additional charge, but would not necessarily be enabled by default. So the ONC's number 4 best practice. This is kind of, well, I don't want to say a no-brainer. Controlling access to PHI. What they're talking about here is what I would call perhaps proper user account management. This is really a There are actually a few HIPAA security rule requirements that revolve around this. In a nutshell, it's the concept of authorization and authentication, making sure that users that you are granting access to electronic protected health information. I say PHI here, that's protected health information. Now we're really talking about electronic protected health information, so that's the information in our electronic medical record systems, right? The people that you are granting access to must be authorized. They must have a legitimate business need to access that information. So the process for granting access to these systems should start with the authorization, and the authorization should come from what I like to call a data owner or system owner. So really a good idea to have predefined who the owners are of your various systems. If you have one electronic medical record system, assign the data owner, who is somebody fairly high up in the organizational hierarchy, as far as making business decisions as to who really does have a legitimate need to know. And that is the person, or maybe the person has a backup as well, that can authorize access, and then access can only be granted by, say, the IT department after the authorization has been received in writing, say an email. And this user management process should also include process for terminating access. Very important, but easy to forget. So that this is all should be a part of our information security program already, hopefully by now. Unique identity means that each user logging into our EMR system must have their own username or identity that is specific only to them. In other words, don't use shared accounts. And I see that a lot, and I'm always, trying to convince people to move away from that, because you really lose something called accountability when you do that. If you're trying to review your records of who did what in your system, you're going to see the username that the user logged in as under that log. And if the username is user1 and the entire endoscopy department logs in as user1, then you really don't know who looked up that record or who did what if you needed to do some type of investigation. So, and again, that is HIPAA security rule requirement as well, unique user identity. Also remember that as hard as we try to not have protected health information stored on our PCs, more often than not, if we have scanning stations or imaging modalities that collect patient information or images or whatnot, sometimes those images or scanned documents, PDF files perhaps, may stay on the PC that's controlling that unit. And sometimes, and I've run into this myself, the practice doesn't even realize that. So they'd say, no, we don't have any ePHI, we don't save ePHI to PCs. Everything is done through, Citrix or through our application that's hosted off-site. Well, just remember to look at those scanning stations, and as you're coming up with your controls to control who can access to PHI, remember those scanning stations as well as just the applications. And there are ways that you can control permissions on the folders that save those PDFs, so your IT department can certainly help you out with that. Number 5, well, physical access. This seems to be starting to stray a little bit from the internet connection, I know, but again, this is the ONC's document, and I wanted to give it to you the way that they gave it to us. So physical access, we have a requirement, again, in the HIPAA security rule for workstation use policies, workstation security policies. Lost or stolen laptops and other types of media storage devices really are not even just a major source of unauthorized disclosure, but last I checked, the #1 source of unauthorized disclosures or breaches. When it's an important decision when you're deciding whether to let your users take their laptops, their tablets, what have you, home or to the hospitals or off-site at all. It becomes a risk. And in my opinion, the best control or the best way to mitigate that risk is just encrypt the whole bloody hard drive. on all of those devices, because now if the laptop is stolen, whoever stole it can't do anything with it. Not only can they not access EPHI, but if you use the right solution, they won't even be able to boot the thing up. Even if they try to take the hard drive out, or not try to, they do take the hard drive out and try to install it in another device to try to just get access to your data, they still won't be able to do it. Laptop whole disk encryption, great, great, worthwhile investment, I think. Even if you're not going to let users take your laptops home, laptops can still be stolen right from the practice, right? So this is a great control from that, because as you may remember, we've got this fairly new breach notification law that requires us to notify everybody under the sun, it seems like, if we've identified a breach or even a potential reason that some patient information may have been disclosed in an unauthorized fashion. And if it's more than 500 patients, then we're really in big trouble. However, they're only talking about unprotected patient information. So if our laptops are encrypted, well, it's not unprotected patient information anymore, and we no longer need to notify the world, the media, the OCR, and all our patients of an embarrassing security breach. So, yeah, locking up servers, again, probably nothing to do with our internet connection, but yeah, if you've got servers or computers in-house that have protected health information on them, then they really should be in a room that is secured, and you control who has keys and so forth to that room. Backup tapes, similar to the laptop and tablet situation, can be stolen, especially if tapes are moved off-site. Really need to have a secure mechanism for doing that, and sure, there are backup solutions out there that will actually encrypt the tapes. Highly recommended. Otherwise, some other way of securing those tapes really is very, very important. And not just backup tapes, but any type of portable storage devices, USB, portable drives, thumb drives, and that type of thing. So all physical security type stuff there, but certainly still important. And limiting network access. Well, yeah, so the number 5 was physical access. Maybe we think of this as sort of logical access or electronic access. We have hopefully a firewall policy, a network security policy that describes what the requirements are, for example, for being able to connect to the network. We've got probably wireless access. WLANs stands for wireless local area network, wireless access. WPA, WPA2, web terms you may not necessarily be familiar with, but those are ways of, or controls for protecting access to our wireless networks and encrypting that access. So if you have a wireless network at your practice and it requires some type of what may be called a key or a passphrase in order to access it, then that's because it's either WEP or WPA protected network, as it should be. But we also may have wireless networks that we're providing for our patients to be able to get to the internet. And if we're doing that, we need to make really certain that that is a separate wireless network that cannot access our internal systems. That's very, very important because you're generally going to maybe even not have a password on that network, and it's just a service to your patients. You're giving them perhaps limited bandwidth out to the internet and so forth. So, and that's a good thing to do, and it can be done safely. But make sure that you enlist somebody that really knows what they're doing, and that your policy states that that network will not have access to internal or trusted systems. And next month, by the way, as you know, we do this tech hour, the second Tuesday of every month. Well, September's topic is going to be all about wireless LANs and how to secure them and how to provide Wi-Fi, public Wi-Fi access to your patients securely and all that. So if you're interested in that, I really hope you'll join us the second Tuesday of September. BYOD. This thing, I get emails all the time about BYOD. Bring your own device. It's just a huge topic right now, especially in healthcare, and it's really the concept of, do you allow your users to bring in their own iPads and their smartphones and connect them to the network and access and stuff like that through their own devices that you don't control, you don't control the antivirus software running on them and all that. So that's a whole other type of risk. And in fact, that might even be another great topic for yet another tech hour. But for now, just make sure that you consider that in your network security policy or whatever policy, as far as, are we going to allow users to do that or not? If we are going to, what are the requirements going to be for that? And remote access, we've mentioned this a few times already, really must be managed and monitored properly to mitigate the risk, or to make it a manageable risk. The risk is going to be there if you allow it, no matter what. But you need to do your due diligence to make sure that that risk is manageable, right? And another thing that I think I would include in this policy is be careful, be wary of what you allow your users to do with the PCs. Okay, if you can make sure they're not administrators, that's great. Make sure that they can't just install software on their PCs whenever they want. That should go through IT, right? Plan for the unexpected, contingency planning, right? What do we do when we talked about the availability when the system goes down? Well, if our connection to the internet goes down, then basically our EHR system is down if it's outsourced, right? So have a plan for that. We kind of talked about that risk-based decision already. Can we operate without that application? And if so, for how long? What are we going to do after that time period expires and so forth? Maybe we fail over to another circuit if we have it. So those are parts of our contingency plans. Data backup and recovery plan, not really helping us all that much as far as the internet connection goes, but still important. And it's still, again, the ONC's number 7 cybersecurity best practice. So when you're thinking about data backup, obviously if the application is outsourced, well, I shouldn't say obviously, but understand how that gets backed up, and things like recovery time objective and recovery point objective. Okay, whether you're backing the stuff up yourself because you have the system in-house, or whether it's outsourced, you want to know how long a recovery would take. How long will it be before I'm back up and running if the server that's running my electronic medical record system crashes? That's recovery time objective. Recovery point objective is basically, well, how much data am I going to lose as a result of this crash? What I mean by that is, let's say your backups run at 8 p.m. or start running at 8 p.m. every night, and it's Thursday. So on Thursday you come into work, and your backup, you have a backup of everything that was done up until 8 p.m. Wednesday. 4 p.m. on Thursday the server crashes. Well, now when you get restored, you're going to be back to 8 p.m. Wednesday. So everything that was done between 8 a.m. and 4 p.m. on Thursday is not recoverable because it was never backed up, and that's what we mean by recovery point objective. And since I brought that up, there are backup solutions out there that don't back up just at a certain time, but actually take periodic, what we call snapshots, or usually called snapshots, periodically, sometimes as frequently as an hour. So if recovery point objective is something that's important to you, then certainly talk to your IT department if your system is in-house, or talk to your provider if it's off-site. And also backup media. If you have a major catastrophe and you're backing up your systems in-house and you're keeping your backup tapes in the server room, well, you may have lost those as well, and then it's kind of game over as far as being able to recover. So probably if you're doing your own backups, you're saving at least a daily or weekly backup copy off-site somewhere. But remember that way that you transport it off-site, that needs to be done securely, and you want to make sure that nobody can get access to those backup tapes. Right? Same thing if it's being outsourced. Your provider should be handling that, but you might want to have an understanding of how that is done. Good computer habits. Yeah, I guess we're kind of talking about acceptable use policy type stuff here. In the HIPAA security rule, what I call acceptable use policy, the law calls a workstation use policy. This is where you describe what your users are allowed or not allowed to do with your systems that provide access to your electronic medical record systems and so forth. So you could call it a no-brainer, sure. Again, this is the ONC, but here are some recommendations I would give you. Define somewhere, perhaps in these policies, who is responsible for management of the system as far as making sure that it gets patched, because patching is very important to protect against these internet-type threats, right? Malicious code and so forth, because patches generally, the goal of patches, or security patches anyway, is to close up the vulnerabilities in these systems. And the vulnerabilities in the systems are exactly what the attackers are looking for and going after, and that's how they're going to get in, by exploiting one of these vulnerabilities. So a good patch management program is going to keep those vulnerabilities closed, hopefully. Application updates, again, sometimes application updates include security patches. Another reason to keep applications updated is, well, to make sure you're compliant with meaningful use requirements, but also to make sure that your application is still going to be supported by the vendor and that you can still get technical support. So you want to be running a version of your application that is supported. Change management is important. If changes are made, you want to be able to have rollback plans and stuff like that. This is really more, I think, availability type stuff, having a change management policy and program, but certainly good computer habit. Capacity planning is basically knowing ahead of time, for example, that you maybe your server's running out of disk space before it actually does run out of disk space and go and crash on you. So kind of part of proper system management and monitoring. Device and media controls also falls under good computer habits. If you can avoid the use of things like thumb drives and little external USB drives that you could plug in and fit in your pocket, then yeah, sure, do that. If your policy can say, they're not allowed, great. That'll make it a little bit easier. It's an easy policy, but it's not an easy one to enforce. But at least having the policy, you're somewhat covered there. Because those are dangerous, just the fact that they're easy to steal and go undetected. And then educate the users is one that I added. And if you've been to any of my or attended any of the previous webinars that I've done, you know that training users is something that I mention in every single one of them, because it's just, in my opinion, hugely important. So make sure your users, you help them out with understanding what good computer habits are, what your acceptable use policy is, and how to detect suspicious activity. Those are the main reasons why it's important to train your users. And protect the mobile device, kind of similar to what we were just talking about with the portable devices, but we're going to focus really more on laptops and tablets and that type of thing. Reason being because you may allow your users to take them off site. We talked about already the importance of encrypting them. Okay, in my opinion, that's I would consider that a requirement, not a recommendation. If your users are taking tablets and workstations or laptops off-site, encrypt them, please. Pre-boot authentication is part of whole disk encryption, where the laptop will not even, let's say it's a Windows laptop, which in most cases it is. In order for, if you've got a whole disk encryption with what's called pre-boot authentication, the laptop won't even boot into Windows until an authorized or user has put in a username and password, a valid username and password to get the thing to boot up. And that's what I meant earlier when I said that if somebody steals a laptop that has the full disk encryption, they're not going to be able to do anything with it. And again, even if they pull the hard drive out and put it in something else, that hard drive is not going to boot. All right. And then secure removable storage devices. Yeah, if you can't get away with saying that USB portable thumb drives and so forth are not permitted because they're needed for legitimate business purposes, well, you can actually encrypt those as well, and those are even easier to steal than hard drives. So that encryption, I think, is kind of the obvious control for that if you do need to use that. Iron Key, by the way, is a company that I like. I have an Iron Key thumb drive that I keep customer information when I'm doing security assessments and so forth, and I have to save data as I'm working on the projects. I make sure it's saved to the encrypted partition of my hard drive and or my encrypted Iron Key thumb drive. So if it does get stolen, I don't need to worry about, losing or somebody else accessing my patient's security information. Here's BYOD again. Remember, that's bring your own device. Are you allowing your users to connect their own devices to the network? And again, the risk of that is you don't control those devices. You didn't install the antivirus software and all that. So unless you write something into your policies that say, geez, we have the right to monitor what you're doing, review the configuration of your devices and all that, then probably the best thing is to just not allow it. Just keep it simple. So again, that's mobile devices connecting to the network, whether they're connecting wirelessly or just connecting into what we call the wireline network, where you have to actually plug into one of those plugs in the wall. So here we are, number 10, establish a security culture. Well, yeah, this again, I think is just another way of stating the importance of training. And like I said, if these 10 best practices were in some type of order and I were creating this one would be up near closer to number 1 than number 10. But like I said, I don't believe these are in any particular order. But the security culture, your users are either going to be one of your worst vulnerabilities as far as security breaches, or they're going to be one of your most effective security controls. And what is going to dictate the difference, or which it is really training. Certainly culture and attitude and all that, but those are going to be sort of controlled, for lack of a better word, by you through the effectiveness of your training program. And you don't, by culture, we don't want your users to be complying with, say, your acceptable use policy just because it's your acceptable use policy and it came down from senior management. I think it's much more effective to have your users want to comply because they understand the bad stuff that can happen if they don't comply. Geez, if I do bring my tablet in here from home and it doesn't have any virus on it, and some malicious code gets on here, now my tablet could be used by an attacker on the internet to get access to my patient's information. And I'm a caring person working for this practice, and I don't want my patients to have to go through the pains of identity theft. So I want to do my due diligence to prevent that from happening now that I understand what that is. So that's what an effective training program should do. It should sort of modify the culture, change the culture of the organization so that all of your users that have access to your systems understand the risks and are willing, for the right reasons, to do what it would take to protect that stuff. So that's why I just hound on the importance of training in every organization. And here's a good one too. I think this is probably from the ONC. Leadership should set a good example. Don't, the policies should apply to everybody. I've actually seen this before where, this chief medical officer or whatever says, well, geez, that's great that nobody can get to these websites, but I'm a chief medical officer and I don't want to be limited by these policies. Try to avoid that. Instead, try to set as senior management, try to set a good example for the way you want your users to behave. So. And we're really nearing the end here. Wireless LANs. This is sort of a teaser, if you will, for next month. We're really going to talk about wireless LANs, but I mention it here because of the riskiness of it, especially of doing it incorrectly, adding wireless LANs. Because at the top of today's presentation, I mentioned that one of the main risks to connecting your practice to the internet is the fact that it bypasses all of these physical controls and other types of technical controls that you were so carefully implemented. Well, wireless LANs kind of do the same thing. In many cases, I could sit out in the parking lot of a practice and detect the wireless LAN, and a clever enough attacker or a improperly secured wireless LAN may be able to be connected to from the parking lot. And if that wireless LAN provides access to your EMR,